Okay, welcome back. We're going to start the next chapters. So we're going to go ahead and move into chapter 2. We're going to actually skip the first section. We'll be returning to that at the end. But section 2 is going to be focused on solving equations. And today we're going to be finding zeros of a function. So at the top of your page, go ahead and write down the essential question. How do I find the zeros of a function algebraically and by looking at the graph? So today we're going to have 3 examples. The first one is actually going to be a kind of complicated looking graph, and we're going to find all of the x-intercepts and y-intercepts for that function. So let's see, there we go. Okay, so let's go ahead, draw in these curves. It's basically going to look like an M. Don't worry about being symmetrical, because we're actually going to label the points as they are. So let's go ahead and label it like this. So here I have negative 6, 0. Over here I have negative 2, 0. Here I have 0, negative 5. Over here I have 3, 0. And finally I have 7, 0. Okay, so just looking at this function, our question is, what are the x and y intercepts? And to do this by looking at a graph, it's actually very simple, especially when you're given the graph. All you need to look is where does the function actually intersect the x and y axis. So here obviously being our y, here being our x. So our x-intercepts are going to be negative 6, 0, negative 2, 0, 0, actually not that one, 3, 0, and the last one, 7, 0. For our y's, we only have one y-intercept because our function only intersected the y-axis at one point, and that would be 0, negative 5. Now in some instances you're going to have it this easy where the graph is given to you. In other cases you are going to have to graph the function itself and then determine by looking at the graph where your intercepts are. For some people that's actually more difficult, and it's easier to solve them algebraically, which is what we'll do in the next example. So in example 2, you're going to be asked to find the zeros of the function f of x equals x squared minus 2x minus 15. Now when we're talking about the zeros in terms of this function, we're actually looking for the x-intercepts. So x-intercepts, zeros, same exact thing. And by that, we're saying that the y value is going to be equal to 0. So we need to find all values of x that make this true. In order to do this, you set your whole function equal to 0, because remember that f of x is just a fancier way of writing y. So we're going to set the entire function equal to 0. So f of x equals x squared minus 2x minus 15 equals to 0. This is actually on your last review packet, and as you guys might remember, at this point you would have to factor. I'm going to go ahead and skip a step because this one's actually pretty easy to do by guess and check. So here I have that x and x, and then over here I have minus, let's see, that's going to be minus 5 plus 3. All of this being equal to 0. After that, you set each one of those terms equal to 0 and solve for x. So here you get x equals 5 and x equals negative 3. So the zeros for my function are going to be x equals 5 and negative 3. Alright, so that's all it takes to find the zeros when you're given a function. Sometimes you just have a very simple linear equation. Sometimes you have to factor a quadratic. Alright, and the final example, very short and simple. Let me go ahead, push this down. You're actually just going to verify if certain values are zeros of a function. So for this problem, I'm going to ask you to verify that x equals 2 is a 0 for the function f of x equals 3x minus 6. Literally, all you have to do is take that x value and substitute it into your input. So you would have f of 2. And by inputting 2, you also have to input it for the other x. So 3 times 2 minus 6. That's going to be 6 minus 6, and that gets you 0. Because our result is 0, we can confidently say that x equals 2 is a 0 for the function f of x equals 3x minus 6. Alright, those are the 3 examples. That's pretty much all you have to do in order to find the zeros of a function. If you need to, go ahead and rewind, replay if as needed. That's the end of this video. Have a good day.